Yeah. So last day we were here, and we looked into like how we can infer whether a particular user is hateful or not using a very simple diffusion algorithm. Okay. Now we left at a note that we want to verify how good the algorithm or the heuristic that we have developed is. And in order to do that, what we did was like we picked up some 100 users, like from this set of uh, like labeled users, if you may say so. And then we asked two annotators to give their judgment as to whether these people are actually hateful or these people are actually non-hateful. Okay. So annotator one, as you see here, has an agreement of around 87% with the prediction of the model. So if the model is telling it's a hateful user, okay, the diffusion model, then the annotator one is agreeing with this, okay, with this judgment of the model in 87% of the cases. Okay, that's how you read it. Similarly, for the non-hateful users, annotator one actually agrees around 92% with the model predictions. On the other hand, for annotator two, it's even higher. Like for the hateful users, it agrees 93% of the times with the model predictions, and for non-hateful, the annotator 2 agrees like almost 100% with the predictions made by the model. And the agreement between the two annotators, which is usually measured using some metric called Cohen's kappa. Okay. So this is usually a metric that is used to measure the annotation parity between two annotators. Okay, and what we see is that the kappa value is pretty high. So something above like 0.55, 0.6 is already very good. And we see that the kappa value is pretty high for both the classes. And therefore, we can say that there is like a good confidence in what the model has predicted. Okay, so in order to further do some more fine-grained analysis, what we looked into are like the uh, distribution of the hateful and the non-hateful users in the hateful topics vis-a-vis non-hateful topics. Okay, so topics are basically some niche communities in GAB. So basically, if you look at the GAB structure, GAB social network structure, you will see that the messages are organized around topics. And we tried to look into what are the topics in which mostly the hateful users make their post, and what are the topics in which mostly non-hateful users make their post. Okay, so basically we wanted to see if the topic names that like we observe for the two classes actually ring a bell. So the question that we asked is like, which topics are mostly popular among the hateful users vis-a-vis the non-hateful users. Okay, and what we came up with is a following distribution of topics. So in uh, the topics of interest for the hateful users are marked as HT, and the topics of interest for the non-hateful users are marked as NT. So do you see some striking differences from the topic names? You see no differences. So uh, like uh, if there is silence, I would take the liberty to assume that you are seeing no differences. Is that the case?
A stage inclined towards some certain
Uh-huh.
community. Hateful topic inclined towards some certain community, black or Jewish.
Yes. So, and it seems that the topic name itself is hateful. Okay. For instance, Jews are the synagogue of Satan. The black race sucks. So these are some of the topics. These are some of the topic names. Okay. These are some like very uh, like well organized topics that one observes in the gap platform. And you see like there are um, certain topics which are kind of, from the name itself it suggests that they are kind of against certain communities. Okay, they are hateful against certain communities, and we observe that the hateful users tend to post in these topics more. Okay, the hateful users that we detected using our diffusion algorithm. This is not the case for the non-hateful users. Okay, they tend to post messages in like standard topics, which has nothing to do with any specific religious or ethnic community. So this is another evidence that the detection that we did using the diffusion algorithm is actually making sense. So the last thing that we also looked into is what kind of URLs are being shared by the hateful users and the mm, uh, non-hateful users. Okay, so and you see, so these are some of the URLs that are being um, or domain names that are being primarily used by the hateful users in their posts, whereas the non-hateful users have a very different set of um, domain names that are being shared. And here also you will see that there are certain URLs which are known to be highly extremely right, okay, in their alignment. So again, what we see is that the hateful users that our model has detected actually uh, are kind of subscribing uh, to the rightist ideas or far rightist ideas, and therefore it gives us even stronger evidence that okay, what we have detected using our algorithm is pretty good to go. So these are the three sets of things that we did in order to show that the algorithm actually detects a reasonably good set of or a reasonably um, like correct set of hateful as well as non-hateful users. Okay. Now, once we have got this hateful and non-hateful users, what do? We wanted to check like how their messages, how the messages posted by each class spreads in the network. So this was our primary question, right? How the messages posted by these two separate classes. So we want to see the messages posted by KH and the messages posted by NH, and we see like how deep down into the network they have gone. So in order to do this, we bring in the concept of cascades. So what is cascade? Now cascade is a path traced by a post as it is reposted by the different users. So a user posts a message, then some other user reposts that message, then some other user reposts that message, and so on and so forth. So this is called the cascade of the that message. Okay, so basically we want to see which user or which message, I mean whatever way you call it, influence which other messages or influenced which other users. Okay, so this is what we wanted to check. Now, the problem here is that since this is a graph, it might have cycles, and we will see in a moment how cycles can come in, and therefore tracking an exact influence path is kind of almost impossible. So what do? We use certain heuristics to convert this graph into a special type of a graph called the directed acyclic graph, a DAG, where like you do not have any cycles, and therefore you can actually trace the influence path for a message. Okay, so that is what we are going to exactly do in the next slide. So let's say you have a network structure like this. Okay, and the links here show the follower-followee links. So these are the follower-followee links. Now, these numbers here that you see are timestamps at which a particular message has been posted. Okay. Now, say for instance, A has posted a particular message at time t equals 0. Okay. Now, consider this node C. Okay. Now, this guy is actually following A as well as following B, and B seems to have received the message at time t equals 100. So A has initiated the message at t equals 0, and B has received this message at t equals 100. Now C has received the message at t equals 300. Now there is a natural question that whether C has received the message from B or directly from A. How do we decide on this? Okay. Unless and until we decide on this, we will not be able to trace the influence path. Okay, so this is an important question that one needs to answer before like tracing the actual cascade path. Okay, so how do we do this? Now there is no standard like algorithm that can help you find this out. So people tend to resort to heuristics. One of these heuristic is called least recent influencer. The other one is kind of uh, the counterpart, most recent influencer. Okay, so in this study we used the least recent influencer heuristic. So basically the earliest person who has initiated the message and whom C is following becomes the influencer of C. So here A is the earliest among A and B, and since C is following both of them and we are following the LRIF heuristic. So we would assume that C has received the message from A directly. Okay. So one can also do the experiments with MRIF, and we also repeated the experiments with MRIF. Results don't change much. Okay. So we will go ahead with the LRIF heuristic. So again, repeating. So you have nodes like this who follow multiple users, okay, and the message could have come from any one of them. And in that case, you need to decide from whom the message had come. Sorry, I got disconnected for a while. Okay, so now you have two sets, the hateful users as well as the non-hateful users. And you know what messages have been posted by the hateful users and what messages have been posted by the non-hateful users. For each such message posted by a hateful user and a non-hateful user in your list, you construct cascades. Okay, so these kind of trees. Okay, so taking each hateful user and each of their message posted, you construct such cascades, okay, such cascade structures. And in this way, you have a large number of cascade structures. Now, from these cascade structures, you try to estimate certain properties, certain known properties of a cascade. Now, what are these known properties? So some of the known properties are as follows. So the first among this is the size of the cascade. That is the number of unique users in this DAG. Okay? So you just simply count the number of unique users in this DAG. That is the number of nodes, basically. Then depth. This is the length of the largest path in the cascade. Okay? So you can find out the largest path in the DAG, and that is your depth. Now you find out average depth. What is that? Average depth is the depth of each path from the root node. Okay, so you find out the depths of each path and then you average it. Breadth is like the maximum width of the cascade. Say for at some point in time, the cascade is as big as this. So this becomes the depth of the cascade. Okay, so you can use a label or a traversal to find out the the breadth of the cascade. So then there is structural virality. So basically, this is the average pairwise distance between any pair of nodes in this particular tag. So this is the shortest distance. Okay, so the structural virality indicates that if there is a message at some node in this network, how fast on average will it reach to any other node in the DAG. Okay, so that is what is indicated by structural virality. So you measure this set of properties for the messages posted by the known hateful users as well as the messages posted by the non-hateful users, and you try to see if there is any difference between them. And you do this for different types of messages. One is the original post made by the hateful and non-hateful users. The second one is only those posts which contain some form of multimedia. Right? And the third one is posts in specific topics. Okay, posts belonging to certain topics. So you have the all the posts taken together. You have posts subsetted by the multimedia, only posts which have multimedia, and then you have also posts which belong to certain topics. Okay, and you do experiments in order to find out all the previous metrics, all the previous cascade metrics that we have discussed using the DAGs that we prepare from the messages posted by the known hateful users and compare them with the non-hateful users. And what are the results? So the results are as follows. So KH represents the known hateful users, NH represents the non-hateful users, and these are the different features that we have just now discussed, averaged over all the cascade trees in the KH set and compared it with the cascade trees in the NH set. And what do you observe? The simple observation that you make immediately is that the size, the depth, the breadth, the average depth, the structural virality, all of these are larger for KH, okay, compared to NH. So compared to NH, all of these factors are larger for KH, and these results are statistically significant. That is, the distributions of the values of size across all the KH posts is very different from the distribution across the NH posts. Okay, and this is true for all the other characteristic features also of the cascade. So these are very strongly significantly different. Fine. So this tells us that posts of hateful users actually, so using a quantitative method, we have now been able to show that posts of hateful users have a larger audience, spread wider, spread deeper into the network, and are more viral. Okay, so larger audience is by size, wider is by breadth, deeper is by depth, and average depth, and more viral is by structural virality. So all of these values are more for the KH users compared to the NH users. Okay, and this actually holds for the other types of posts, like the posts which only have multimedia, the posts which are made in specific topics. And what you see is that the differences get more pronounced here. it's even more. If there is multimedia present, then the spread actually is even more strong for the hateful users. So this actually tells us that if a platform is left unmoderated over time, then hateful content is going to spread much more deep, much more wide, and is going to be much more viral compared to a normal content, okay, compared to any normal content. Okay, so this is something that is that could be very alarming. Okay. So we also looked into some temporal plots, like on the x-axis you look at the cascade parameters, and on the y-axis you always see time. So what you observe is that the time required to reach a particular size, okay, by the hateful community is much smaller compared to that of the non-hateful community. So recall that this is time. Okay, so the time required to reach a specific value of size is much smaller. So basically the cascade of the non-hateful users reaches a larger size faster than that of a non-hateful user. So the speed is also something that is mattering. So, and it is known that usually in a network, the early influencers or the early adapters actually make the largest impact. Okay, and therefore it is important to understand the impact of this largest or the earliest set of adapters, and this is what is getting reflected in this particular picture here. So for all the plots, if you see, what we observe is that, I mean, roughly, grossly, you see that there are, so the a particular characteristic, a particular cascade characteristic is reached faster for the hateful users in comparison to the non-hateful users. So this is again a second level of problematic issue. Okay, this again is equally alarming. So the first thing that we observe is that on an aggregate level, there is this tendency of the hateful content to spread deeper, wider into the network, as well as these types of hateful content actually manage to reach a larger number of people at a smaller time, okay, compared to any like average post made by some non-hateful user. Okay. So now in the next half an hour, we will discuss a little bit about like how one can envisage to actually uh, slow down this process of spread of hate speech. So could there be a mechanism which can help slow down this process of fast spread of hateful content in the social media? Okay, so the immediate solution that comes to our mind is something like, you know, you block or suspend the, as I was telling you, like Twitter has this very stringent policy that like if hateful content are monitored from a particular user account, then like initially they would uh, remove those messages, and it might be like also leading to a suspension of the account if there is a regular activity of posting hate content from that particular account. Okay, and then there are also laws established by different governments across the world. So these are like hate speech laws that have been established by different governments in order to ban the spread of hateful content. Okay, and also like social media websites, as I was telling you, are taking like various steps in order to monitor and moderate hateful content, exception being platforms like Gab, which actually say that they are like, followers of free speech. Okay, so but then this has its inherent problem. Like if you try to block or suspend somebody's account, like they can come back and say that, okay, you are curbing my freedom of speech. Okay, so as an individual, as a rightful individual, I have the like scope also to express my viewpoints on my social media account. So therefore, there is always this tug of war between, or a very fine line between what is, free speech and what is hate speech. So many a times this distinction is very difficult to make, and therefore there is always an ever lasting debate that whether this kind of blocking and suspension is actually harming the freedom of speech idea or not, or is actually a bottleneck in like in in the promotion of freedom of speech, which is something that probably all the social media platforms actually subscribe to. So then what is a middle ground? What is an alternative solution? So an alternative solution, which was like deemed to be quite effective by a specific campaign that was launched by Facebook, is this idea of counter speech. Okay, so you try to counter attack the hateful post, okay, using some valid arguments which themselves are not hateful. So you do not want to fight hate with hate. That's not the idea. So basically, you try to counterattack the hateful arguments using a series of like additional arguments, or which we call more speech or counter speech, okay, which will kind of dilute and in fact in some case nullify the effect of the hateful content. Okay, so that's the idea. So as I was telling you last day, that many of the hateful content that we observe are actually born out from fake news. Okay, so therefore, if you have a counter speech or a counter attack to the hateful content, showing evidence that this particular content is fake, then that itself serves your purpose as a counter speech. Okay, so this is one way that you can actually promote counter speech. So there are a lot of NGOs and in fact many social media websites that are coming up with such counter speech campaigns. Okay, so here we will discuss the next paper that talks about this kind of countering online hate speech. Okay, so yeah, we have already discussed like what is counter speech. So it's basically trying to resist or dilute the hateful posts that are being made on various social media platforms. Okay. So in this task, what we did was we curated comments from hateful videos. So we actually collected some around 30 plus hateful videos, and we looked into their comments. So we scraped their comments and we only looked into the direct response. Okay, we do not take the reply into account, just the direct response to that hateful video. And we imagine that a portion of this direct response is going to be counter speech. So that was the hope, that was the hypothesis, that since this is a hateful video in the first place, so therefore there might be some people who will come and look into these videos and actually post certain messages which can kind of dilute the effect of the video. Okay, so and in this case we took three specific communities: the Jews, the blacks and the LGBT community. Okay, and this data set actually contains data about all these three types of communities. So there were few videos, few hateful videos towards Jews, few towards blacks, and few towards LGBT. It was like kind of 10 plus 10 plus 11 or something similar. So yeah, so these are some of the examples of such videos. Okay, so many of them have now been removed by YouTube because of its hate speech policy, but then these are when we collected them, like they were still there, and we were fortunate to get these comments. Now once we got these comments, like we observed that counter speech could be of various types. Okay, and this was not the first time that we did it. Like there was earlier work by Benesh in 2016 who showed that counter speech can be in fact categorized into multiple groups. So like one group is presenting facts to correct misstatements. Okay, so this is like, you know, the one that I was telling you, like you tell that this is completely fake, and in that way you prove that whatever the hateful content has been talked about is a product of fake news. Okay, then pointing out hypocrisy or contradictions in the statements, warning of offline and online consequences. These are typically legal consequences. So you tell people that, okay, if you are posting such hateful messages, then like you might have to face legal consequences. So then there is this idea of affiliation. So this is like, so suppose you are affiliated to a certain religious community, and some person from your community is hurling a hateful message to some other religious community. So you stand for that minority religious community and say, no, no, this is not correct. Whatever is being done by one of the fellow members of my religious community is not correct. This should not be done. So we are all like equal and things like that. So you affiliate yourself to one religious community and support some other religious community, probably a minority religious community. Okay, so then denouncing of hateful and dangerous speech, of course, like you can denounce that. So you can say that this is whatever you are doing is not correct and things like that. Okay, so then there is humor or sarcasm. So you can respond using humorous comments like, do you in this age also do you believe in this kind of hateful remarks and things like that. So you should get educated and things, all these things come into play in this category of counter speech. Then there is of course positive tone, like you try to nullify the effect of hateful content using certain positive like remarks and things like that. And then there is hostile language, as I was telling you, that there is always a scope to fight hate speech with hate speech. Okay, but this is not what is something that we would really expect. So we would not want someone to hurl more hate speech in order to, combat with hate speech. So this is not something that should be typically done. It's not advisable. Okay, so we used some standard techniques, like we had the JSON files, and so by scraping the YouTube comments, we like got the JSON files, and then we did two levels of annotation. In the first level, we asked the annotators to mark a comment So in the first level, we ask the annotators like whether a comment is a counter speech or not. And in the second, we ask them like what category of counter speech. Okay, so these are the two levels of annotation that we did. So in the first level, we had like kind of 50-50 class separated comments, like we had around 6,900 counter speech comments and close to 7,000 non-counter speech comments, and the agreement between the annotators was pretty high, like so therefore like we have enough confidence in this data set that we gathered. So and it's the good part of it is that it's like kind of pretty balanced. So, and then in the second level of annotation, we asked the annotators to like whatever. So we had the 6898 counter speech comments, like we asked the annotators to segregate them into one or more of these categories. So for instance, like a particular counter speech could belong to one or more of these categories. Okay, and the annotators had a free hand in labeling each of these counter speech comments with like multiple levels. So we did not restrict them to one single level. So, and here also the kappa value is pretty high, and so we were confident that whatever annotations we have done are like usable for our further experiments. Now, if you look into the distribution of the data, what you observe very unfortunately that a large number of these counter speech comments are actually hostile. So basically people are trying to fight hate speech with hate speech. Okay, so this is something that is typically not advisable, but this is what we are seeing in the data. Okay. However, if you leave aside this part, you start seeing certain interesting trends. So let us for the time being like be oblivious of this particular set of counter speech and look into a little bit more deeply into the rest of the table. Okay, so we immediately see that certain types of counter speech are more popular in certain minority communities, okay, or in certain target communities. So for instance, in the Jewish communities, it seems that positive tone is something that works very well as a counter speech, whereas in the blacks community, warning of offline and online consequences, that is legal consequences, is what works best, okay, in diluting the hate speech. Whereas in the LGBT community, it's either pointing out hypocrisy or pointing out or like making it a subject of mockery. These are the two things that work best or are the most like frequently chosen modes of counter speech for the LGBT community. So you see, based on the community, there are distinctions in way counter speech is done. Okay, so not all communities actually, for not all communities, all types of counter speech work well. Okay, so for certain communities, certain types of counter speech. So that's why we wanted to do this categorization and see like if they have varied effect across the different communities. Looking into a little more deep, like we found out the number of likes obtained by this. So these are certain metadata. So we found out the number of likes obtained by these counter speech comments in the different communities. So for instance, this is the black community. And in the black community, you see, as I said, legal consequences and denouncing hate. These are the two types of counter speech which garners a lot of likes. Okay, so the average number of likes by the community is largest for these two types of counter speech. So seems like these two types of counter speech works pretty well with the African American community. Okay, and these are some of the examples of such counter speech. For the Jewish community, we see that affiliation is one of the most liked form of counter speech. Okay, so if you remember, I told you that affiliation means somebody from some religious community affiliates himself or herself to that community and votes for or vetoes for some other minority religious community. Okay, so that is what is affiliation. It seems like for the Jewish community, the kind of counter speech that works best or is most liked by the audience is the affiliation based counter speech. Okay, and for the humor, as I said, like we also saw in the data distribution itself, that humor and sarcasm, sorry, for the LGBT community, as we also looked into the data set, humor and pointing out contradictions and hypocrisy are the best ways of, I mean, seems to be the most likable ways, if you say, of like countering hateful messages toward the LGBT community. Okay. So next, we also went on to, identify or automatically try to detect whether a given piece of text is counter speech or not. Okay, so and we did it again. We did the problem again in two parts. One was like a binary classification where you have counter speech and non-counter speech, whereas the second one is more like a in-depth thing where you try to also identify one of the different categories of counter speech. So once you have classified something as counter speech, you try to next also identify what type of counter speech it is. Okay, so and we use some very simple models. So at that time, like deep learning was still becoming popular, and like we saw that even using some very simple like um, features like the sentence vector, the TF-IDF, the bag of word vectors. So these simple things with a standard classifier like XGBoost or MLP, etc., they gave us pretty decent results. Like we had an overall F score of 71%. Okay, so of course this can be boosted further. Like, I mean, one can think of using more advanced deep learning models like the transformer based models, but the problem with transformer based models is that they are very data hungry, and uh, like the counter speech and non counter speech data that we have is actually like not so large to train these transformer based models accurately. Okay, and then we also did, as I said, the multi-level classification. We use some very similar type of features and very similar type of off-the-shelf machine learning algorithms. And here again, like on a 7-class task, we achieve a pretty decent F score of 60%. So that was kind of the story of the counter speech annotation and detection. But then you might ask, like, why do you guys went on and like tried to detect counter speech in the first place? Like this is more like a generation problem, right? So like these days NGOs are involved in like posting counter speech messages, but most of these activities are manual. So it would be nice to have an automatic method to generate counter speech. So given a hate speech as a cue, can one generate counter speech? But see, in order to do that, the first thing that we need to do is to, have a good training set. Okay, have an automation in the first place to understand what are the things that differentiates between a counter speech and a normal speech. Okay, so in order to learn this, in order to have a precise understanding of these differences, we wanted to go for this kind of a classification task in the first place. So once this classification is done, and if we could, so if you understand that while the binary classification is kind of still manageable, but this category level classification is something that is not so easy, I would say. So, and if we had some sort of automatic classifier, and if the inputs of this classifier could be somehow fed into the generation mechanism, and say given a particular type of hate speech, if we could generate the appropriate category or the most suitable category of counter speech, then that would be most effective. So in order to do that, we had to learn the distinctions between the different categories. Like what are the different distinctions, what are the different characteristics that makes one category different from the other. And that's why we launched this detection task in the first place. Presently, I mean, if you guys are interested, you can get in touch with us. Presently, we are trying to have a full-fledged generation pipeline where some of these detection mechanisms are actually helping us to fine-tune the generation model. Okay, so if you are interested, we can look into, I mean, we can talk about more on this, like in some free time after your semester is over. Now, people often ask me, like, so this is a note that I want to finish this class with. So people often ask me, like, why are you so interested in doing research on hate speech? So basically, like, so unless someone himself or herself has experienced the bitterness of this particular vicious thing, it's very difficult to motivate to do research in this area. And something very similar happened in the past, and I myself have been a victim of hate speech. So I guess a pretty lot among you know that I have restricted mobility. And so I was teaching this course in 2019 where I got a decent feedback. And then when I looked into the subjective feedback, this was one of the comments that was hurled. And that kind of further strongly motivated me to pursue this area of research, because I feel like there are many others like me who are witnessing similar situation but do not have enough machineries, enough weaponaries to fight this ill from the online as well as the offline world. Okay, so we'll stop here. Any questions?